Hello everybody. This video is going to show you how to create jobs and job pipelines in the NIRS Toolbox, or Brain AnalyzIR software, which is the new name for it. So I've created this quite quick script in MATLAB. I've added the NIRS Toolbox. This is the newest version of the release into my MATLAB path. If I click run here, I'll go line by line here, so I'll go ahead and put a stopping point. Go ahead and click run. This is actually going to ask me to add it to my path, which I will. Next, I need to select my data file. So I happen to know that I have some finger tapping experiments hidden away here, right here. So if I go to this folder here, it will basically dig one by one through these files, and it's actually going to search for a .NIRS file, which I've actually designated in the next line. If I go deeper into each file, let's say I just select this file, it will only look in that folder for a .NIRS file. Where I'm at now, it's going to go by each one, and it's going to compare, it's going to basically consider each of these a group. Excuse me, a subject. So I go ahead and select folder. So next, it's going to create a raw object, which is using the load directory function, which is in the NIRS. So if I open up NIRS Toolbox here, bear with me, here we go. So I go to plus NIRS as a coordinate here, open that up, I go to plus IO, which is right here, and inside that I will find the load directory function. In the load directory function, if I open it, you'll actually see, depending on how I call it, it will look for a .NIRS, a .oxy3, a .WL1, or a probe with a CSV extension. Depending on that, it's going to call any one of these functions, which all will load the data based on what the extension says. So because I'm specifying .NIRS, it's going to use the .NIRS function. If I didn't designate any of these, it will actually look for all of these. That's actually quite useful unless you have more than one type in that folder. If you have more than one type, it will load each one individually as a different subject. So that's a little dangerous. I did call the folder format, or the folder hierarchy, as group followed by subject. So basically the first folder will be group, the following folders will be subject. That may or may not be correct based on how you've organized your data. So I'll go ahead and step ahead, and you'll see here it's loading, it's gone through all of them, and now I have my raw variable. So here, if I open up the raw variable, I have two .NIRS folders with two .NIRS files in them. So now I have two data sets. Each one has the following properties, which actually has the data, the probe information, the frequency modulation if available, any auxiliary measurements, the stimulus vector, or in this case dictionary, and demographics about your subject. The second one looks identical. I can move forward, and I'll actually skip over the next few bits, which are a little less interesting. This section here actually looked for coefficient of variance, so I'll skip ahead to the jobs. So if I've set a stopping point there, I go ahead and move forward. We've run everything. Now I'm going to start to push forward on the jobs. So the jobs basically are organized in such a way where the input to one becomes, or excuse me, the output of one becomes the input of the next. So here again, just as before, I go to the NIRS folder. So if I back out here, here's the NIRS folder. I find the modules folder. There it is. And here you have all the various modules. Once I call that to begin my pipeline, I will call an empty module, and in this case, optical density with no input. Once I run that, the output will be saved in the variable J. If I step forward, I open up J, and you will see I have a name and a previous job. There is no previous job because it's the first job that I've called. Depending on what job you're calling, it will have modulations available for the input, and you can do that by actually opening them up. So if I just jump in, you can actually see how to call it. And here you'll have various inputs. In this case, I'm going with all the defaults. So I run the optical density, the output becomes the J. From there, I take the output J, put it into this next method, this next module, which is the Beer-Lambert law. This will take the optical density and convert it into concentration. So now if I open up my J, it will not only have the name of my current job, as well as some default values, which you have access to change. but it will also have the name of my previous job, which I can then open up and see and continue this in a step-by-step fashion. So I save the output as the new J, and now I'm inputting that new J into this final method called GLM. And again, that's going to be in the same folder that we're in at the moment. So once I run that, the new output, again, will be saved in J. Here we have more input values that I had the option to alter when I called GLM. But now I can open up the Beer-Lambert law previous job. From there I can open up the optical density previous job, and I can keep going as long as my list continues. Finally, every method has the option to do a run function, a run, every object, I guess, every job object has the option to do a run method if we're sticking to proper vocabulary. So now in order to do that, I just call the variable .run. I do have to put in my input value. In this case, my input is my data object, so I go ahead and click run. It will take a while, and you can actually see that it will have some processing dots just to keep you updated as to how it's going. And now I've run it on 2 data sets because remember I had 2 .NIRS files in my folder. And now I have an href channel stats variable or object. So I can open that up, and you'll see I have 1 and 2. That's for each data set. Here you have the variables, which if you open that up, you'll actually see source, detector, hemoglobin type, and the condition. If I open up the beta, I now have my beta values. That's going to be in the number of channels multiplied by the hemoglobins multiplied by the conditions. I also have covariance matrix, I have the probe information, I have the basis function, I have conditions, I have t-statistics, the p's and the q's, I have everything built into this channel stats object. What is most interesting, at least as far as how to present the data, is now I can actually present it as a table. All you have to do is call the href. You have to pick which data set you want to call it on. Let's call it on data set number 1, and then I hit table. Once I run that, you have a wonderful table. You can actually save this as a variable if you like, but here you have the source, detector, hemoglobin, condition, you have the beta value, the standard error, the t-stat, the degrees of freedom, the p's, the q's, and the power. All this is printed neatly on a table. If you do want to save it as a variable, you would actually just call the same function, just as so, but we could call it TBL, href TBL, let's call it that. And run that, and now I have this wonderful table with all of my values. So that is actually how you would go about a basic processing stream in NIRS Toolbox, as well as how to actually more or less export your data, or at least show your data in a table format. So there's much more that you can do with this toolbox, but that will give you the basic run through of at least how to get started. I do hope that was of use.